Okay. On to chapter 2. Way less definitions. So everybody should be happy about that. However, we get to do some calculations and stuff now. So chapter 2 is going to look at a lot of graphs and organization of data. Okay. The first thing, actually, though, is I need everybody to email me by next Tuesday with what your project you're thinking about doing is, and if you are going to be working with anybody else in the class. Okay? So by next Tuesday, I need that. This way, I can have a conversation with some people depending on which topics you're looking at and like how we can go about collecting that data. All right. The first thing you're going to start to do with that data after you collect it is to actually start organizing it and doing what we're going to be doing in chapter 2. So it kind of works out kind of nice. So by next Tuesday, send me an email, tony.baker@ctstate.edu, my college email, and let me know what your subject is going to be, what kind of question you're looking at answering. If you have an idea of how you're going to collect the data, great, put that in there. If you're going to work with other people, remember you can work with up to 2 other people, so a group could be a max of 3 people. Okay. And if you have any other questions with that, you can see me after class or send me an email and we can discuss that too. All right, so 2.1 is organization of qualitative data, and 2.2 is going to be quantitative data. So first off, let's look at a little definitions. What is qualitative data?
Descriptive quality.
Right. So remember we were talking about last week, eye color, anything with words automatically is qualitative. There are some number ones like phone numbers, social security numbers, things like that are qualitative that are not quantitative. So things you cannot do real calculations on is qualitative data. The first thing we're going to look at is how to create a frequency distribution. So a frequency distribution is a table that lists the category of data and the number of occurrences for each count. So, for example, in this one, we have some survey results, A, B, A, C, B, A, D, A, B, C. And all you're doing is counting how often those results come up. All right? So each category is the value you're looking at. So if I was going to go through in here and I was going to make up one based on eye color, I could count all the people who have brown eyes, blue eyes, hazel eyes, and then that would be my category, and then my count would be how many of each of those occur. So frequency distribution is literally just counting. Any question on frequency distribution? When you're going through and counting them, honestly, tally marks work really, really well. Just little marks. Depending on how big the list is, it can be a little pain in the butt to actually do, but tally marks kind of helps out a lot there. The second part with a frequency distribution is what's known as a relative frequency. So we have the count, but the count is going to be based on how much data I have. So if you go around and collect eye colors and you collect 100 different people, and I go around and collect eye color, but I only collect 30 people, you're obviously going to have more brown-eyed people than I am, or blue-eyed people than I am, because you collected more data. So how would we compare those two sets of data to be able to talk about them at the same thing? We couldn't just use the total number, because obviously the person who collected more data is going to have more of those. So relative frequency allows us to take those and turn them into a percent. Percents are very good to be able to talk and compare things because it's always done out of 100. That's why it's percent, per 100. So you take your data, we take the number, the category frequency, and we divide it by the total observations. So in the one we just looked at, category A had 4 occurrences, and there was 10 total numbers. So A occurred 40% of the time. Everybody a second to write that down. I need to fix that. Now, once we have a frequency table, so we can see here, yeah, those are really small numbers. Let's see if I can make them bigger. Maybe. Not easily. All right, it's fine. We'll use the graph. It's not a big deal. So I had my numbers. I had 5 A's, 5 B's, 3 C's, and 2 D's. One of the methods, you ever heard of the picture is worth 1,000 words? So I could list those, put the frequency, put the relative frequency next to it, throw it on a newspaper, throw it on a website, and most people are going to gloss right over it and not even look at it because there's numbers and we don't like numbers. So pictures are worth 1,000 words. If I put a graph there with bars and they're colorful, it will catch the person's eye and they will look at that data a lot more frequently than if it was just a bunch of numbers. So that's why we have graphs. So a bar graph is what you see here. It is literally just a count of how many you have, and the length of the bar is what it is. You can have it like this one. This is a horizontal one, or you can have it vertically going up and down. Okay, they're both a bar graph. They're both the exact same thing. I need to change and add a few. All right. Oh, by the way, so I'm going to show you 2 different ways to be able to do a lot of your homework. This is actually on my website. So this actual, the frequency distribution calculator, you can type in any information you want up here. It will give you the categories, the frequency, the relative frequency. It adds a percent and as your pie chart, which we're going to talk about in a little bit. It will also give it to you down the bottom. It will show you a bar graph, which we just talked about. The other type of graph is known as a Pareto graph. And I'm probably pronouncing it wrong. So a Pareto graph is a bar chart. However, it is in order of highest to lowest. Okay, so your bars will always be the highest to lowest. A bar graph is typically organized by the data. So if it's a bunch of words or the eye colors and things like that, it's typically ordered in alphabetical order. These are not. So I don't particularly care for these because these can be used to show, like, manipulate your views, because the highest ones are always going to be first. And a lot of times people focus on the picture and not necessarily on the numbers and words underneath. So, but this is a specific graph that you can use and you might be asked for it. So understanding what it is important. Pie chart. So every single administrator that I've ever known in school loves pie charts. And every boss loves pie charts. Pie charts are not for everything. You have to have very specific things to use a pie chart. First off, it has to be able to be put into a percent to be able to be turned into an angle. It has to add up to 100%. If it adds up to over 100%, it cannot be a pie chart. Okay? The pieces of information have to be distinct. All right? So if I was asking you what colors you're wearing as an outfit, every single person in here is wearing more than one color. So if I just counted up all the colors, I would have more data points than I have actual people in here. Okay? So if I did my relative frequency, it would actually be over 100%. I could still make a frequency table from that. I can still look at it in a bar chart. I cannot make a pie chart out of that. Okay? So pie charts do not work for every single set of data. They're very pretty. They make nice little circles and stuff, but they don't always work. So, for example, so this is what a pie chart looks like. Okay, so a pie chart, you're going to take your percent, your relative frequency, and you're going to multiply it by 360 degrees. Why are we going to multiply it by 360 degrees? Yes. That'll come back on in a second. Because what did you say? Sorry. Yeah, a circle has 360 degrees in it. So, I don't know why it keeps flashing. It's the projector. So, 360 degrees in a circle. So, therefore, we multiply the relative frequency by that, and that gives me my central angle, which then you can use to draw your pie chart. Nobody in here is going to be doing a pie chart by hand. You're going to use a calculator to do it. Or you're going to use like StatCrunch or things like that online, which I'm going to show you how to do now. I think that was it for this one. Yes. All right. So this is one of your homework problems from chapter 2.1. And you'll notice in your assignments, I'll show you. So you'll notice some of the assignments, and then some of the assignments say StatCrunch homework. StatCrunch is a website that's built into MyLab. It will allow you to do the calculations online, and it'll help you figure those things out. Okay? So when you go into your homework assignments, so this is one of the problems here. This was, we're ordering random tornadoes. Click here to view the table. Here's the table of values. You'll notice a little box up here in the corner. This box says open in StatCrunch. Yep. Absolutely. So this is the homework assignment. You're going to click right here where it says click here to view random sample of tornadoes, which is what you need to fill in this chart. So you click there. And then there's a little box up here in the corner that says open in StatCrunch. You can copy it. If you really like Excel, if you're one of those that like Excel and using it, open it in Excel. Totally fine. You can use Excel. When you open in StatCrunch, a page like this is going to show up. And it looks daunting. It's like, oh my God, all this stuff. It's a pain. Not that hard. Actually, this is way easier than what it was last year. All right, let's see if I can make this bigger. Some of these actually allow me to make them bigger. Some they don't. Okay, this one does. So you'll see up at the top, applets, edit, data, stat, graph, help. Here's all your data. If we want to sort this data, we can do this as a bar chart. Or, let's see, do they have frequency? Have summary stats, tables, right here. So here's tables. Frequency. We wanted a frequency table. That was one of the questions that was the first part of this question. So we click frequency. Now this one was asking for the frequency of the scale of the tornado. So I could scale and compute, and there's your answer. Okay. Now, I will go through all that again for you. So the goal for this assignment was we needed to figure out the frequency and the relative frequency for those scales. Click the table, send to StatCrunch. It opens this. All this data will already be there. You do not have to type this data in. It copies it over. For your frequency tables, you're going to look at stat, and here there's a whole bunch of stuff in here. And a lot of this stuff we're going to do over the course of this semester. Right now, we're looking at tables, and we want frequency, because that's what we're talking about. It then wants you to pick which one we're talking about. You can pick state, scale, or day. They were asking the scale of the tornadoes. So click scale and click compute. And there's literally the answer to the question. I don't think you can copy this over. Wait, hold on. This would be funny. I don't think this is going to work, but no, it does not work. Okay. You do have to type them over. Now, if I sort by frequency, that now makes it that paleograph if I really wanted to look at it. It's now in order there. Scale, that's how you typically would have it. What if I needed a bar graph of this? We would go to graph, bar plot. With data or with summary? We want with data. Let's look at state. I happen to know that's one of the other questions. And here is the bar chart for each state and the frequency of them occurring. So which state occurred most often? Texas. That's how easy it is to look at this once you do it. So if we think about it in terms of all this data, there's 100 pieces of data here. If you had to go through and count them all out, it would have been a lot of work. StatCrunch and computer technology allows us to do this quite easily. You can do this just as easily in Excel, but this is all built in, so it's nice and easy. Which state had the least amount of tornadoes? Massachusetts is one of them. Alabama, Hawaii. Who would have thought Hawaii had a tornado? Montana, North Carolina, New Mexico, New York, Ohio, Pennsylvania, and Vermont were all one. And you can literally click on them and actually see what they are. Apparently, I can't unclick them once I've clicked it, but that's okay. Does that part make sense on how to use this to do your homework? Yes. Yep. We're not to 2.2 yet. I will get there. There's a slight difference in 2.2 compared to 2.1.
For
yes.
This, I'm on Pearson trying to find those links. I don't know what. I can't find those. I went through every single question on the 1.3.
It's not on 1.3. 2.1.
Oh, 2.1.
Yeah.
So that's what I'm thinking.
No problem. Yeah, this is the 2.1 and 2.2 homework. So this is 2.1, 2.2. I'll get you. If I don't answer your question by the end in 2.2, tell me, but I will get there. Okay? Yeah, it depends on the question. Like, not every question is going to have it. Like, this question's in 2.1. it gives you the graph over here, but it doesn't give you Stat Crunch. You're just going to look at it to figure it out. Yes.
So I'm looking at question 7 on the.
Yeah.
So in StatCrunch, I tried to sort it by frequency in relation to each other, but it just keeps saying the frequency is 1 for all of them.
So here's frequency. This is that problem.
Yeah.
And the question was asking you for relative frequency.
Right. So how can I set it to do relative?
So calculate tables frequency.
Oh.
Right here,
I
relative
went to
frequency.
graph.
And it should, there's, no, it comes out to be all 0.2. Why? Oh, I know why. Hold on. Nope. I will figure this out. Hold on. Why is it? Honestly, this one probably was one easier just to do it ourselves, but it's going to bug me now. It should be under calculators, but it's not. I will tell you, okay, I will figure it out later. This one's actually easier just to calculate yourself. Just add them up and divide it by how many you have. That's all you do for relative frequency. Since this one's not a huge set of numbers, it's probably just as easy to do it yourself. Not everything is going to be easier in StatCrunch. Graphs and stuff definitely going to be easier. All right. Any other questions with relative frequency or frequency distributions? Or with pie charts? Okay. All right. The difference between 2.1 and 2.2, 2.1 is qualitative data, 2.2 is quantitative data. That means all of my data is going to be numerical, which means I can do a lot more stuff with it. Okay? So we're going to have two different types of data displays. We're not going to go a few of them, but let's first we're going to look somewhat at what we just did with the frequency table. The first one is discrete data. Discrete data is when everyone has a specific number in it. So remember we talked about discrete and continuous the other day? Discrete data is 0, 1, 2, 3, 4, things like that. Continuous is every number. And actually a question came up in the homework for chapter 1, and it was discrete data is countable, continuous data is not countable. Because technically you can't count every single number between 1 and 2. Because there's an infinite number of numbers there. So discrete data you can't. If I was doing every half, it'd be 1, 1.5, 2. That's fine. If I was doing 1.1, 1.2, I can count those. But if it was continuous, it was every single number, you couldn't count it. So if you got that one wrong, that's fine. Discrete data is countable, continuous data is not. So discrete data I can organize very similar to what I just did with my frequency tables. Okay? So you're going to set the bars over, just like we did with our frequency table. So here is the number of children per family. So I have 0, 1, 2, 3, 4. There's my frequencies, and there's my bars. It looks very similar to a bar graph. What's the difference between it, though? There's one big difference between this graph and the bar graphs we were just looking at, other than the fact that it's the other direction. This one's a bell curve. They don't always have to be. Like, they don't necessarily have to be a bell curve. The key with a histogram is there's no gap between the values. Because they're distinct and discrete numbers, there's no numbers between them, so I can put the bars together. Okay? So 0, there's nothing between it. It's 1, 2, 3. So there's no gaps in a histogram. So discrete data, very similar to frequency table. Just count them up, put them in the bars. There we go. So now, here's the question. If it's continuous and every single number counts, I can't organize it the same way. Okay? I'm not going to be able to count how many 2.3s there are, or 2.35s there are, whatever else, because every single number in between those would count. So to do a continuous data, we need to set up classes. So we need to organize the data into groups. So instead of organizing them to 0, 1, 2, 3, 4, we need to organize them into groups. For that, I need a lower class limit and an upper class limit. The lower class limit is the smallest value that can belong to that class. The upper class limit is the highest number that can belong to that class. And the class width is the difference between those two numbers. So we subtract them. Now, before I get into the class width formula, the little thing down the bottom is actually very important. The classes cannot overlap. So I cannot have a class from 10 to 20 and then from 20 to 30. Because then the question is where does the 20 go? Okay. So when we're organizing our classes, they cannot overlap. So classes from like 10 to 19, 20 to 29, 30 to 39, that works. Because that means every number between 10 and 19 is going to be in there. And I know exactly where the numbers are going to go. Now again, these are looking at whole numbers, but they're continuous. So technically there is numbers between 19 and 20. When we're looking at organizing and creating our classes, we create it with one more decimal place than what the data is going to show you, so you take care of that problem. So we'll talk about that in a little bit, in the organization of it. So like if I'm having whole numbers, 10 to 19 is fine. But if I'm going to have decimals, I might do 10 to 19.9 or 10 to 19.99. So this way I make sure I keep all the numbers within there between those values. Your class width. Your largest value in your data minus the smallest value divided by the number of classes you want. You choose this. This is not necessarily like you can choose the number of classes, or for your problems in the homework, they will tell you the number of classes. Or they will tell you the class width and you have to figure out the number of classes. But it's always the largest value minus the smallest value overall in all of your data divided by the number of classes. And you are always going to round up. Never round down and never stay the same. Because if you go down, you're going to run out. You're going to have to add another class at the end because you're not going to have enough classes for all your data. So you always round up. You'd rather a little extra space at the end than having to add another class. All right, so here's an example. The minimum value of my data here is 67. The maximum value is 95. So I would subtract those two. And I get a 20, my range is 28. And this problem, I want I said I wanted 5 classes. So if we did 28 divided by 5, we get 5.6 for my class width. But I'm going to round up. So I'm going to round up to 6. So my class width is going to be 6. Any questions on how we did that calculation? Yes.
Not exactly, but this does kind of pertain to the question that
Yep.
I had. Because in these questions, it wants you to get the relative
Yep.
frequency, but it has like a range. Like it says like.
Yep, I'm going to show you how to do it.
Okay.
That's the next piece, actually. Almost there. All right, so questions on class width? We're good with class width? What's the key? Always round up. Any of the calculators I'm using, these are all on my website. You can use these to do your homework. So if you really like StatCrunch isn't working for you, you can throw the data right into these if you just copy and paste it. Yes.
Well, I'm on it right now on the website, and it just says like read only. How do I make that?
It says read only.
Yeah, like, I can't click on it.
Then I might have to fix something.
I was gonna do it.
Oh, you can't do it on there. It's actually on the pages in the study guide.
Oh, so there's a link.
Yeah,
Oh,
it actually, the calculator is built right in.
Gotcha.
Yeah, you can't do it on this one. All right, so now, here is the answer to your question. Once you have your frequencies, or once you have your classes, we organize the classes out. So my lowest number was 67. So I start my class at 67. I'm going up by 6. So I go up to 72.9. Okay, 6 would go up to 73, but I can't go to 73 because that'd be the next class. You notice the 67, 73, that's the difference of the 6. Then 79, 85, 91. We always go 1, remember I said 1 decimal place? So since these are all whole numbers, I'm going to go to 0.9 for the one before. So that's where all the 0.9s come into play. Frequency, just count. We'll deal with midpoint in a second. Frequency, you're just going to count. So in this case, I have 25 total values. Your relative frequency, you're not calculating it based on the numbers, you're calculating it based on the frequency. So I take that 4 and divide by 25. That's how you get the relative frequencies.
Oh, so you're just doing, so you don't have to calculate.
No, you're not counting how many numbers are in the class, you're counting how many times that class appeared, which in this case is 4. Okay? Now, when you set up your histogram, the discrete histogram had the numbers in the middle because they were single values. You'll notice these have my class numbers. Those are the class boundaries. So 67, 73, 79, 85, 91, and then my last one is 97. And you notice my data only goes up to 95, but my classes go up to 97. That's fine. That's because we rounded up, and we had that little extra on the end. So we have the bars go together because technically there is no gap between the data. Questions on those? Okay. Midpoint. The other way that you can show your histogram, you can show it with midpoint. So instead of putting the numbers up here, you could put your midpoints in the middle of the bars. So the midpoints, you just add the two numbers up and divide by 2. So the midpoint between 67 and 73 is 70. And 76, 82. So those are my midpoints. Both of those ways are acceptable ways to draw your histogram. Okay, so either the class boundaries or the midpoints. The midpoints are going to come into play later when we start looking at how to do averages and weighted averages. The last one I have on here is cumulative. You have cumulative and you have cumulative frequency. Cumulative frequency is you're just adding up the frequency as you go. So you can see how I got 4. The 9 is because it's the 5 plus 4. 15. 6 plus 5 plus 4. So it's just cumulative as you go up. You can also have cumulative relative frequency, where you're just adding the relative frequency up. So if it's asking you for cumulative, you're adding everything up to the point where you're at. So if I wanted the cumulative frequency up to 70 or up to this class here, it'd be 15 because I'd add the ones before it. Any questions on the histograms? Did I totally answer your question on relative frequency now? Awesome. Next graph, stem and leaf plots. Anybody ever heard of them before? This might be the first graph that we talk about that you haven't heard of before. Stem and leaf plots are basically a histogram where you actually show all your numbers. The classes are fixed to either tens, hundreds, things like that. So a stem and leaf plot, if this is my simple data here, 25, 25, or 23, 25, 31, 34, 34, and 42. My stem is the tens. So 2, 3, 4. My leaves are the ones column. The 3, the 5. So you put this together. That's 23, 25, 31, 34, 34, and then 42. So the leaves are your ones column, and your stems are your tens column. And if you look at it, those are bars. This is a bar graph with my class width of 10. Because that's all my 20s, that's all my 30s, that's all my 40s. So you can use a stem and leaf plot to organize your data and to create a bar graph with a specific class width. You also can have what's known as back-to-back stem and leaf plots. So if we wanted to compare two sets of data, so say I take my 4 o'clock class or my 7 o'clock class and I want to compare your test scores, I could create a stem and leaf plot with both of your classes up. In the middle, it's still your tens. So in this case, the lowest grade in this class was a 60, in the 60s, my highest was in the 90s. So this is class B, so 62, 64, 67. Class A was 65, 68, 69. What do you notice about how the numbers are put? They're in order. Yes. Which means that helps you figure out things. So when we start to look at calculating out for means or modes and medians, this puts all your data in order, which helps you figure those calculations out. All right, so it's a very nice way to organize a lot of data in a really small space. Because you're just writing the one column and the tens is already taken care of. Got it? Okay. I just want to see if there's any. So you can see here, actually, let me make the bigger one. See, sometimes your lines can get quite long. That's fine. It can happen. It's not the end of the world. This is a really good example. I'll fix another one in a second, but this one, you'll notice that sometimes if the column's too long, you can do a double line of them under it. All right, let me actually get the data for the double one. All right, so this one is a before and after of something. Doesn't tell me what, which is fine. But if there's nothing here, that means there's no 30s. Okay? That means 70, not nothing. Okay? So if there's nothing there, you don't put a single number there at all. Don't put a 0. Because a 0 means that's data, that's information. So this means 70. If that 0 wasn't there, there would have been no data points in the 70s. Yeah, 70. So remember, the stem is your 10s and the leaves are your 1s. So you put it together. So that would be 70. Like this would be 64, 66, 67, 68. Questions on stem and leaf plots? Okay. Dot plots. The least favorite of my group of graphs. A dot plot is literally just a bunch of dots on a graph. You put all your points on there, and the points are that value. So for here, I have 2 1s, 2 2s, a 3, 2 4s, and a 5. You just count the dots above the numbers. And they also make a nice little bar graph.
So those dots that are
There, yeah, it's slightly off.
okay, so that's not saying like 1.2.
No, it's still 1. That would be a bad HTML. So like this is actually a lot better group. So here's the number of siblings. So here's my data points. And you can see, so there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people that were surveyed that had 1 sibling. Trick question. If I have 1 sibling, how many kids do my parents have? Right. As crazy as it sounds, that's sometimes the questions that the homework and things will ask you. Okay, and it's like it's those little things like, no, the answer is 1. Nope, it would be 2 because there's 2 parents. So you have to be very careful when you're reading the problems. All right, because especially when we're looking at this data in the different types, qualitative, quantitative data, and stuff like that, you do different things with it. So if they ask you a specific question or they give you certain data, that's going to help you determine what you can do with it. Last one. We're going to get into this a lot more down the line. Identifying distribution shapes. So when you're looking at a histogram or less less a bar chart because you really can't do much calculations with those. So the difference between a bar chart is for qualitative data, a histogram is for quantitative data. So most of these, when you're going to look at this type of stuff, it's going to be quantitative data where we're going to be doing calculations for. Uniform means all the data is basically the same. And their example is rolling a die. Every number on a die has the exact same number of chances to come up. Okay. The bell shape, the symmetric curve. We are going to become intimately involved with the bell curve by the end of this class. Because pretty much everything we're going to be doing is going to be revolving around that bell curve. IQ scores, heights, SAT scores, pretty much any set of data that when you start to collect a lot of it is going to fall into this symmetric curve where the majority of the data is in the middle, and as you get further and further out, it becomes less and less. Sometimes we do have data that is skewed right, and sometimes we have data that is skewed left. As long as it stops flashing. Can anybody tell me how you would determine skewed left and skewed right? Yes. Okay. So if this word wasn't here, what would you tell me that was? Skewed right or left? So where is the skewing is what? The peak or the tail? It's the tail. I know that's, but your thought process is exactly what people think, and it's really easy to mess that up. Okay, you're not looking at the peak; you're looking at the tail. Okay, so when we start to look at mean, median, mode, and those calculations, the tail is what pulls the information in that direction. So, like this one was income distribution. The majority of people are in that lower half. However, you have some people that are way over here. And if you look at their income, will pull the averages in that direction. That's why it's skewed right, because they're pulling that information to the right. Skewed left, age of retirement. When you retire, you're typically, a lot more people retire later than earlier. So if you're retired really young, you're going to be in that tail. You're going to pull the retirement age down to you. Okay? Or a really easy exam test. You're going to have a lot of people that are going to pass and get great grades, but you're still going to have some of those people on that low end. Okay? So when you're looking at skewing left and skewing right, you are going to look at the tails and not the peaks. Okay. All right. We're good. Any questions you have? So as of right now, chapter 1 should be done in the homework. Okay, if you're still working on chapter 1, I would highly suggest getting that done soon. Chapter 2, we just did 2.1 and 2.2. You should be able to do those. I will tell you the chapter 2 homework is probably easier than the chapter 1 homework. A lot less reading. A lot less of those definitions and things. Use StatCrunch. If you get stuck or things aren't working right, send me an email, send me a text. Take a picture of what you're doing so I know what I'm looking at. So this way I can figure out how to do it, and then I can send you back an explanation. And what do you need to send me by next Tuesday? Your project. What are you looking at doing? Okay. The earlier you send it, the better, because then I can actually explain, go back and say, this is where we might be able to make some adjustments to it. But you have to get it to me by next Tuesday. All right. If you have any questions, I'll stick around. If not, I will see you on Thursday. Yeah.
I never grabbed the sheet that explains explained the project last time, and I was wondering if you either had an extra copy or if you could post them on Blackboard.
It's on my website.
Oh, okay.
If you go to blog, it's right here.
So that's the one, and that'll explain it.
This is the thing I handed out.
Alright.
So you can print that out or use it right there.
Wait, do you mind if I just take a quick picture of that right now?
Absolutely.
Just because I'm a little anxious about it, I'd like to be able to look. Thank you.
You're welcome. What's up?
What is the project on?
It's the Stats in the Wild. So go to my website. It was over there, and I don't have any extra copies.
Okay.
But go to my website. It's right. It's called Stats in the Wild. Your guide to becoming.
Tony.
Oh, before everybody runs away, because I only have a few people right away. Make sure you're logged into my lab. I know I'm going to get an email in the next couple days. Probably by next Monday, I'm going to have to put in if you're here or not. And if you're not logged into that, I will mark you not here, and you'll be dropped from the class. So that's the Pearson thing. Yep. Make sure you're logged into where you can do the homework. If you are not, get there soon.
I didn't know Tuesday, so I don't know about the project. I didn't see it anywhere.
It's on my website.
Is it? Okay.
It's called Stats in the Wild 2026 project. If you, I can print one out for you. Just come see me tomorrow. I'll print one out for you.
Understand it all so quickly. It's so quickly for me. Show me for the second time. Where is homework?
Okay. Billion tabs, but that's okay. Let's go back. Nope, don't want to open text. I don't want the textbook.
Where is it?
Have a great day, Tony.
It was, nope,
It's
it's the blue one, this one. You have a billion tabs.
yes.
And I don't want to close any on you. They're probably all important. You go here, assignments. Here's your assignments.
It's my assignments. It's my homework.
Yes.
Yes.
Yep.
I did it.
Yes.
Where is my homework? Well, next homework.
Right here. And it looks like you've only done one of them. This is chapter 1. Those
Chapter
6.
1.
Yeah, those 6. And then these 2 are the ones I just thrown over today.
Oh, only this.
2-1 and 2-2.
1 and 2.
Yeah, that's today.
What you did?
That's what I did. I did 2-1 and 2-2. Those are the 2 that I did today.
All the notes are on Blackboard.
All the notes are on my website. Nothing's on Blackboard.
Is there a link to your website?
It should be on Blackboard, yeah. It's
Okay.
Baker's math class. It's as simple as you can get.
Show me, please, where you these tables. Where?
Oh, this stuff?
Yes.
Baker's math class. Okay, we're gonna close this one, but I'm gonna type in here because it's the exact same as the other. It's the exact same as the other one. And then we're gonna do this, and we're gonna move it here, right next to the other one. So here's this. If you go to blog, these are my notes. Like this is today's notes for today's class. Okay, so there's the video and everything else.
Side 1, side 2.
I need to put them all.
If you go to study guides, stats,
So yeah, that's below.
2-1.
Either exactly.
Here's all the notes.
Oh,
And here's that calculator that I have.
where is it?
Study guides.
Study guide.
So I've been using.
Here.
So study guide, statistics.
It's yes, I understand. Where is
So I've been
the
trying to
yellow
split
It's right next to your Pearson.
So I've been trying
next?
So it's right there. And what I'm going to do is I'm going to close that because you don't need that one. You don't need that one. You can use that one. You don't need that one.
It's my.
I know I'm trying to clean up some of your other tabs so you might be able to see things.
Oh, yes. Yes, I understand.
You don't need that.
It's
You don't need that.
Do you know how much CD cases cost?
Okay, so here's Pearson. Here's my website.
Oh, that's actually cheap.
And what date is?
By next Tuesday, because I'm going to go over 2.2 and 2.4. I mean 2.3 and 2.4 on Thursday.
I'm not very excited to do this.
What's your math?
Next.
First
Tuesday.
Yeah.
Oh,
You're only doing 4 CDs.
I will write you. I
That's
think.
fine. You can email me. We can talk on. No problem.
Oh, sorry.
What's up?
So my question is, I have like a lot of my other classes is incorporating like research projects. So I was wondering if that's okay if I could just merge them all into like one.
Should be able to.
Okay.
Send me what you're doing, and
Yeah.
we can figure out if it's going to work.
Yeah. So I was my
Like if you're in
research-
psychology or any of those
I-
classes, I guarantee you're doing one that would work.
I am, yeah.
Yeah.
So for my IO, I'm doing why mental health is so discriminated against.
Yeah.
In hiring or selection processes.
Yeah, we can. So the key piece is you're going to have to figure out where we're collecting the data to get that.
Yeah.
To be able to determine that. But yeah, absolutely, we can do
Yeah,
that.
I was thinking of asking previous psychology classes or my psychology teachers if I can give out a form to everyone.
You can. There's probably also a ton of that data already collected online.
Yeah.
We might be able to find some of those data tables and stuff like that.
Yeah.
So, but yeah, we can. Yeah, absolutely. It's
All
something
right.
we can
Thank
do.
you.
You're welcome. Yes.
So, I remember this table you were showing on the screen.
Yep.
I'm looking for the crunch thing.
Okay.
Yeah. I
So
don't
for
see it.
this one, you don't really need it, but
Okay.
it's right here. If you click here, It's
Oh,
that
I was
little link
looking
right
for
there.
that. Yeah.
Yeah,
So
it's right
which
there.
one do I need it for?
so this one is actually going to be easier to do yourself.
Okay.
And the one I was looking at was English question 12.
Oh, question 12.
Yeah,
Okay.
and if you click that, it lists you all the tornadoes. And click that, then open the StatCrunch. It'll open a new window, and there's all your data.
Oh, okay. All right. Take it. What was the project again? Just basically a
It's called Stats in the Wild. Go on my website, the form, the actual sheets
project?
there, the project's there, the sheet that I handed out that first day
okay.
with the rubric and everything else is already in there.
Thank you.
Another question.
You're
is,
fine.
I can't